Good morning, students. I am going to say about the non-deterministic finite automata. How we are converting the non-deterministic finite automata into a deterministic finite automata. So, in deterministic finite automata, there will be a input alphabet which will be containing two symbols which will lead to the state that must be containing these two symbols. We have phi that can be assumed as a dead state. We will be using it for your deterministic finite automata. In non-deterministic finite automata, we will be calculating both the input symbols, that is both the input alphabets will be represented. So here in every conversions, this is the basic things. For every DFA, there is an NFA that has been placed inside it. Okay, but there is no equivalent representation of DFA for every NFA. So DFA is represented by the transition function. We will be representing the transition function for DFA as del, that is capital Q cross X, which is represented as there will be a Q number of states. If it is NFA, means it is represented as 2 power Q. This is our transition function. So let us see the example how we are going to convert this given DFA. Okay, so that is from the NFA how we are going to design a DFA. So design a DFA from the given NFA. So this is a state transition diagram. From this state transition diagram, you are going to convert it to your DFA. How the conversion can be performed is, okay, so here the initial state is represented as a Q0. So the Q0 is represented as your initial state, and the final state is also your Q0, which is represented with a double circle. So here first we want to draw the transition table. Okay, first we have to design the DFA from the NFA. Before converting, first we want to convert the state transition table for NFA. After then we can able to construct the DFA transition table from that NFA transition table. So from the initial DFA, how we will draw is, so if it is 0, initial state is represented as Q0. So the initial state, if it is Q0, it goes to, okay, so here if it is Q0, it goes to Q0 itself. If it is 1, there is no transition. So if there is no transition, it is represented as 5. Okay, and the next state is Q1. If it is 0, there is no transition, and if it is 1, it goes to Q1 itself. So it is represented as 5, and then it is represented here as. So here what we will do is, wherever the transition of input symbol 1 it goes is Q1 and Q2. Then for the state Q2, if it is 0, if it is 0, it goes to Q0. If it is 1, okay, so here if it is 1, there is no transition. So it is represented as infinite. From this transition table of NFA, we are going to design a DFA transition table. Okay, so how the DFA transition table is differ is, first initially as usual we will be writing the initial state as Q0. So initial state is Q0. From Q0, if it is 0, it goes to Q0 and Q1, and Q0 if it is 1, it goes to infinite. So what we will do is, what is we will be considering this as a new state, that is for the initial state Q0 and the input symbol 0 and 1, we will be getting that as Q0 and Q1. So Q0 and Q1 is represented as a new state. Let us calculate the transition from function. Okay, so we will be observing the next state as Q0 and Q1. So Q0 and Q1 is taken as the next state, and we will be calculating the input for Q0 and Q1. So here we will be exposing, okay, we will be exposed the new state. So Q0 and Q1. So what we will do is, we will be considering the Q0 and Q1. If it is Q0 and Q1, it goes to Q0 and Q1 for the input symbol 0, and if it is 1 means where it goes is, so Q0 is alpha, and then if it is Q1 is Q1 and Q2. So here the transition is Q1 and Q2. Okay, for the next transition, the new state is represented as, already here we have represented Q0 and Q1. So the new state is Q1 and Q2. So Q1 and Q2, if it is 0, where it goes, if it is 0, it goes to Q0, and if it is 1 for Q1 and Q2, it is goes to Q1 and Q2. So here there is already the existing state is Q0, and already there is an observed state Q1 and Q2. There is no further more transition to represent on a transition table. Okay, so this is the transition table for DFA. So how we will construct by using the transition representation. Okay, so how we will evaluate is, if del of q0 comma q1, if it is 0, where it goes. Okay, so if it is 0, it goes to q0 and q1 union of 5. So it will be moves to q0 and q1. Next, for the transition of q0 q1, if it is 1 means, so you will be performing the union of del of q0 if it is 1, union del of q1 if it is 1, you will be performing the union operation. It is represented as q1 and q2. Again we will be calculating this as a new transition. So here what we will do is we will be stating this. Okay, so q0 q1. After then we will be evaluating for q1 and q2. If it is 0, where it goes, and if it is 1, where it goes. Okay, that is here you will be performing the union operation to calculate the each transition. Okay, so after evaluating your DFA transition table, what we will do is we will be draw a transition diagram for this transition given that is constructed transition table. So what we will do is, so all the state whether we have been exposed or not, so we will be extending the exposed table. So the transition table will be evaluated based on whether it has been exposed or not. So according to the transition table, we will be constructing your transition diagram. Okay, so for the transition diagram, we will be taking both the input alphabets A and B. So how it moves. Okay, so here the transition diagram is the initial state is Q0. So it is also acting as a final state. And then what is the new state it is created is Q0 and Q1. And the another new state is Q1 and Q2. So wherever the Q0 state has been placed, that state is represented as the final state. So it is represented with a double circle. And then if you are representing the set of state, then that state of state is represented with a square bracket. So square bracket of Q0 Q1, square bracket of Q1 Q2. So from the transition table we will be drawing this diagram. So if Q0 is 0 means where it goes. If Q0 is 0, where it goes is, if Q0 is 0, it goes to Q0 and Q1. Okay, so it is represented as Q0 and Q1. And then if it is 1, there is no transition, and Q0 Q1, if it is 0, it goes to Q0 Q1 itself. If it is 1, it goes to Q1 Q2. Okay, so if it is Q1 Q2, if it is 0, it goes to Q0, and then if it is 1, it goes to itself. So the final transition, here there is no input transition for the input symbol 1, so it is represented as a dead state. So you can replace the dead state as QD. Okay, so this is how we will be constructing the DFA from the given NFA. Thank you, students.